Okay, so these are the 6 trig derivatives that you guys have to know. At some point, you have to have these memorized. What I would recommend in the meantime is to definitely have these on like a formula page or something, because you're going to use them for the next, definitely the next couple of weeks, and then even beyond this unit as well. All right, so there are definitely some tricks you can use to memorize these. But in the meantime, okay, let's not focus on that part of things just yet. All right, let's just focus on actually applying these, and we're going to do this in a few different sections. So a little later, we end up doing chain rule. And when we do chain rule, we'll do some more complicated trig derivatives. We'll return to those. But in the meantime, okay, what we're doing right now is we're going to do some basic trig derivatives. And when I mean basic trig derivatives, what I'm saying is you're not going to see anything like this, okay? You won't see anything like sine squared x. We won't have the trig function squared or cubed or anything. And then another thing that we won't see until next section are things like this, where you have an angle that is not just x, like cosine of 4x or sine of 3x to the power of 4. These things can happen. They involve using something called the chain rule, which we're going to learn very soon. In the meantime, okay, what we're going to do for the time being is we're going to look at trig functions that do not have exponents on them, and also trig functions where the angle is just x. So you see that in these 2 examples here, and in the next 2 examples you see as well. I mean, you look at example C, and you see an exponent of 4, but it's not on the trig function. It's something separate. Okay, so let's take a look at what we have here. All right, we're going to find the derivative of each of these 4 trig functions that we have. So y prime in this case, okay, derivative of sine is cosine. So this would be 3 cos x. That's a one-step problem right there. And for here, okay, basically the 3, it's not an x next to it, so it's not product rule or anything like that. In that term, 3 sine x, you only see an x one time only. So it's just a regular power rule. And then the derivative of cosine is negative sine. So it's kind of like this. It's already a negative. So we have a negative for sine. And of course, 2 negatives make a positive, so let's just simplify that right now. The derivative of cosine is negative sine. The derivative of negative cosine then would be positive sine. And then this is all we have to do here. So the first example didn't use any of the other trig rules that we've learned, like product or quotient rule, but quotient rule is coming up right about now. Okay, notice that in this function, in example B, we have x divided by x. So if you take a look here, let's just remind ourselves, okay, secant squared, the derivative of secant is secant tan. So we're going to remember that or refer to our formulas. And at this point, okay, we're going to use the quotient rule. So we do derivative of the top, which is secant tan. Notice you must have an angle after each trig function. Okay, so the angle is going to remain the same, the angle of x. And then that's times by the denominator, g. And then we do minus f, which is secant x, times g prime, which is 2, all over g squared, which is 2x, all squared. Both the x and the 2 get squared. And we can leave our answer like this. We're not really asked to do any simplification, so this is a correct answer right here. Let's look at some basic simplification that could possibly happen here, just in case you look at an answer key and you see it written differently. First of all, your denominator could be written as 4x squared, because you're squaring the 2 as well. And not a whole lot else that you could do here. You might see the 2x in front, so we could rewrite it and have it look like this. And then another thing that could be possibly done here is that on top you have 2 terms. Terms are separated by a plus or minus sign. And within those 2 terms you have some common factors. You have a 2 and a secant x, and that could possibly be factored out as well. So there's lots of different ways of expressing the same solution. Coming up here, okay, we have some things that are slightly more complicated. Okay, so first of all right, what we have is we have two separate terms, terms separated by plus or minus signs. And in this first term, okay, we notice that we have to use product rule because it's x times x. So within this, okay, what we're going to do is we're going to do a product rule. So we have to do f prime, which is 4x to the 3 times g plus f times g prime, the derivative of tan is secant squared. And that is taking care of the derivative of the first part. And then we do the derivative of the second part, and we remind ourselves what is the derivative of cosecant. And of course, the derivative of cosecant is negative cosecant cotan. So what we have here is we have plus 3 cosecant cotan. If it's already negative and the derivative is negative, then the two negatives make a positive. And then this would be our final answer. Not much to do to simplify that. Okay, there's not really any common factors among all three terms here. We would just leave it as it is. And then for this fourth example here, I could see two different ways of this being done. Okay, so we could use product rule because we have f times g. And that's probably the way that most of you would do this. Okay, you would do a derivative, f, like consider this to be your f, consider this to be your g, and do a product rule. So once again, okay, the derivative of cosecant is negative cosecant tan. All right, as we return to our derivative pages, and we have minus cosecant x cotan is the derivative, that's f prime, times g plus f times g prime, the derivative of tan is secant squared. And of course, there are common factors to take out, or you could use a trig identities to simplify your answer. But technically, this is all you have to do if you're not asked to simplify. Now, another way of doing this one is to go back to the beginning and simplify this expression, this equation right here, using trig identities. Cosecant is 1 over sine, tan is sine over cosine, and you can see that the signs cancel and you get 1 over cosine, and that simplifies to be secant x. And then you can just get the derivative of secant x. That's an option as well. All right, so there's lots of different ways of doing these. And if you're not too familiar with trig identities, then I would just go to this first one right here and use the product rule.